Hi, my dear students. A very good evening to everyone. So, welcome back once again. ACE Engineering Academy, ACE Online live program for the GATE preparation students 2023. And dear students, yesterday we have discussed about. I'm sorry. So, my dear students, once again, welcome back. ACE Engineering Academy, ACE Online platform. Students, yesterday in the analog circuits live program, we have clearly discussed about the strategy, the preparation strategy, the way how we need to go in a sequence order to prepare for the competitive exams like GATE, engineering services, as well as PSUs. Students, after completion of this session, many students requested me to discuss about the numericals with the way how I teach in the class, the tricks, the shortcuts and time saving techniques. Actually, today's session, I thought of taking a particular topic in analog circuits, but many students, they requested to go for the numerical part. And I came to know that most of the students, they're facing difficulties in operational amplifier with the diode circuits, operational amplifier with a transistor, MOSFET, like that. If op-amp output is given to the MOSFET, op-amp output is given to the bipolar junction transistors, op-amp output is given to the diodes. Many students are feeling difficulties, what I realized. So in this session, okay, let us concentrate more on the numerical part, especially for op-amp, diode circuits, as well as the transistor circuits. I hope this session must be very much useful for the students who are preparing for the competitive exams like GATE, engineering services. Is it okay, my dear students? But before that, I could confirm that students must be having some idea about op-amp. If operational amplifier is ideal, and if I can justify that it has a negative feedback, an op-amp which is an ideal, and if that op-amp is having a negative feedback, no doubt, I can implement virtual short concept. Virtual short, inverting terminal voltage is equals to non-inverting terminal voltage. V2 is equals to V1 like that. That must be a very important prerequisite for you guys to understand this topic. Second thing is how to identify the feedback, whether it is a negative feedback, whether it is a positive feedback, or whether it has no feedback. I believe you must be knowing that. If you don't know, just, I mean to say, if you want me to repeat, I'll just show you an overview. Even though in the class we'll be discussing, but I'll show you some overview by that, this numericals. It will be very easy for you. For example, let me take the operational amplifier, guys, the black box. If I take an operational amplifier, say minus and plus, okay. This is inverting terminal and it is non-inverting terminal. If I want to find whether there is a feedback or not, very simple logic, guys. First step is to break the loop. I repeat, just break the loop. The very first step is break the loop. This is the best technique to justify whether the circuit is having a feedback or no feedback. Just break the loop. Once you break the loop, it will be like a comparator, open loop design. It may be V0, yes, guys. So it will be like a comparator. Once you break the loop, you can easily find the value for V0 dash, like V0 dash is equals to, if I say this is differential gain, this is like VID. So differential gain into, you'll be getting it as like VID value. Correct or not, dear students, right? Once if there exists a closed loop, I repeat, once there exists a closed loop, that means there must be a beta circuit, beta factor or beta circuit. There, you can easily find the loop gain. That means, for example, let me assume if this is taken as ground. For example, let me take this as ground and assume there is some closed loop system with a beta circuit. Okay, this is the beta circuit. Beta circuit. Yes, okay. Now, this output is given back to this input. This output is given back to this input. So, overview, if you understand, you will be getting the V0 dash by V0 will be almost in terms of the loop gain beta AD. You need to find the loop gain from this circuit, correct or not, dear students, as we discussed. So if that loop gain is negative, we can say that will be a negative feedback system. If that loop gain is positive, we say that is a positive feedback system. If there is no loop gain, if there is no loop gain, I say, then I could say there is no feedback. It acts as an open circuit system. If there is no loop gain, it acts as an open circuit system. Yes, this must be again an important prerequisite for you guys to understand this concept, today's concept, so-called operational amplifier, diode, transistor, numericals. Yes, okay, now let us start. So if you check it out, the circuits like operational amplifier between op amp and the load. If I say this is the final load, guys, if I assume that is the final load, okay. So between op amp and the load, if you observe any diode or if you observe any transistor, for example, see here, between op amp and the final load output, if you observe any diode or if you observe any transistor, maybe MOSFET or maybe BJT or multiple transistors, like you can go for push-pull configurations like that. If you go for multiple transistors or single transistor, or this output is given to a Darlington pair, okay, whatever may be the case, between op amp and load, between op amp and load, if I observe the diodes or transistors or multi-stage amplifiers, whatnot, guys, then what is the best technique? That is what I'm going to discuss in this particular live session. Yes, okay, I'll give you some shortcut, I'll give you some trick, I'll give you the time-saving technique that adds a great flavor. You know, the very first important point, if that type of circuit, if you see, what is the first step? If you ask me, guys, just assume operational amplifier as a comparator. I repeat, assume operational amplifier as a comparator. That is the first point. Take an operational amplifier as a comparator. Fix it. There is no negative feedback. There is no positive feedback. It is purely the open loop circuit. Operational amplifier as a comparator. The second important point. Now you please justify the status of diode, because the advantage of comparator is, for example, I say V2 greater than V1. What is V2? Non-inverting terminal voltage. V1, inverting terminal voltage. These are the notations we discuss in the class, am I right? So, for example, I say V2, non-inverting terminal voltage. V1, inverting terminal voltage. So, V2 minus V1 is VID, the differential input. V2 minus V1 is what here? VID. If VID is positive, what do you mean by that? V2 is greater than V1. VID is positive indicates V2 is greater than V1. So if VID is positive, VOP, that means what? Open loop output of op amp. Open loop output of op amp, that will become positive. Interesting fact is, as it is a comparator, it will be plus VSAT. Plus VSAT. That must be the largest voltage in the circuit. Correct or not? That's the largest voltage in the circuit by which I can easily identify the status of diode or a BJT or a MOSFET, because this is the largest voltage. If this is given to anode, diode should be on. If this voltage is given to anode, diode should be on. You need not to compare with cathode voltage, because the highest voltage in the entire circuit you are giving to the diode. So why should I compare with cathode, man? It is very easy. So anode voltage must be greater than cathode voltage, because it is the largest voltage, or we say saturation voltage. Correct or not, dear students, right? So VOP, you please calculate from here. I mean to say whether it is plus VSAT or minus VSAT. Once we get that, in the second step, we are supposed to identify the status. Maybe the diode, or maybe the MOSFET, or maybe the BJT. Tell me, dear students, if I have the BJT, you know that when emitter junction is closed, I repeat, emitter junction is closed. That's it. BJT is on. I don't care whether it is in the forward active or saturation. First, I should care that my BJT is on, that's it. It may be in the saturation, maybe in the forward active. Once BJT is on, yes, there is a closed switch, that's it. Is correct or not? So emitter junction must be closed. Emitter junction must be closed. In the similar way, if I go for MOSFET, if gate to source voltage, I repeat, if the gate to source voltage is greater than the threshold voltage, if it is greater than the threshold voltage, that is enough. My MOSFET is on. Gate to source voltage, if it is greater than the threshold voltage, that is enough, man. My MOSFET is on. I don't know whether it is a linear region or a saturation region, okay? But my MOSFET is on. If MOSFET is on, my system is closed. That is my second step. So second step is to find the status of diode, status of BJT, status of MOSFET. That is my second point. And third point, now finally calculate the unknown quantities. Is that okay, my dear students? I believe students are in the chat box. Yes, Nikhil you have, Naresh you have, Aditya says, wonderful. And yes, students are in chat box. Yes, Snehal, yeah, fine dear, fine, fine. The students are in the live. Yes, guys, you must be ready to give reply for the questions what I'm asking here. Is it okay, dear students, right? Take care. Now I believe you got the point. Let me repeat once again, guys. If the operational amplifier output is directly connected to the diode, that means between op amp and the load, between op amp and the load, if diode is there, diodes are there, BJT, BJTs are there, MOSFET, MOSFETs are there, or combined circuits of BJT, MOSFET, any device, man, I don't care. We are here to solve in 3 different steps, that's it, only 3 steps. That's a beautiful trick we have. The very first one is what, dear students? Treat operational amplifier as a comparator. Second point, understand the status of either my diode or a BJT or a MOSFET. Third, just use the network analysis or use the concepts in analog circuits and try to solve whatever the needed quantity we need exactly. That's it. Ready for that, my dear boys and girls? Yes, ready. So let us go with the very first question. Let's come with very simple question, guys, very simple question. See here, if operational amplifier is ideal and diode voltage is 0.7 volt, that means when diode is on, the diode on voltage is 0.7 volt. We are supposed to find the output voltage. This is the voltage with reference to the ground. We are supposed to find the output voltage. So, anybody in the class? So, can I get the answer from the students? You are live, I believe. Yes, we have the laptop, we have the mobile phone. Yes, guys. So, students are in live. Answer, please, guys. Yes. Yes, you please put pen on the paper. Please put pen on the paper. Let me know the answer. Let me know the answer, okay, guys? Now, I'll go with the method, what we have discussed, okay? At least first question, do one thing. First question, you follow me, okay? First question, you follow me. Second question, I'll give some time, by that you can get the answer. Fine, dears? So, the very first question, my dear students, what is the first step? Step 1, we can move in 3 different steps, right? The very first step, what is that, guys? You can understand that op amp is a comparator. So, let consider op amp. Let me consider op amp as a comparator. Correct, dear students? Let me consider operational amplifier as a comparator. Yes, fine. If I take it as a comparator, it shows what, dear students? No negative feedback, no positive feedback, no closed path, nothing, man. It's a comparator. So, no doubt, this voltage, I could say VOP, open loop output of op amp. Right, dear students? Now, as there is no feedback, so here I could say how much this is, guys. This is 1K and this is 3 volt. And here it is given as ground. That's it. And let me know, my dear boys and girls, please let me know. Please let me know, this current will be 0, am I right? Because under open switch, there will be no current propagation. When our current equals to 0, I could say the voltage drop is 0 volt. The voltage drop is what here? 0 volt. So therefore, this is what voltage, dears? Inverting terminal, we take it as V1. Non-inverting terminal, we take it as what, dear students? V2. Now tell me, dear students, what is VID? What is VID? VID is nothing but V2 minus V1. What do you mean by that? 0 minus 3 volt, because no voltage drop, the total 3 volt will be coming over here. Therefore, it will be how much, my dear students? Minus 3 volt. Then what it shows exactly? The output voltage VOP is minus V saturation, because it is a comparator. It is what, dear students? Comparator. So VOP is minus V sat. Now I connect the diode to the system. I connect the diode to the system. I connect the feedback to the system. Now let me connect the total circuit to the system, because in the first case, I just opened everything, I switched on the supply. I switched on the supply, I opened everything. No feedback, no negative feedback, no positive feedback, no diode, nothing, man. I opened everything. Now I realize that, okay, this is the output I'm getting. Now let me connect. Guys, I believe you're getting the points or not, dear students, right? Now, let me check it out. What is the next step, guys? What is the step 2? What is the step 2? Step 2. Tell me, dear students, what is the step 2? In the step 2, we need to identify the status of diodes, right, dear students? Identify status of diode. So, identify diode status. Identify diode status. Yeah, fine. Now, tell me, my dear boys and girls, so this is the voltage what we got as VOP, am I right? This is the voltage. Of course, under open loop, I got this as minus Vsat under open loop. Now, I told you already, this is the highest voltage we are giving to the diode. Highest voltage. That means I just don't care about anode voltage. I just don't bother about anode voltage. Why? Because this is the highest voltage that is going to decide the status of diode. Commonly what we do, anode voltage greater than cathode voltage, then only diode is on. Anode voltage less than cathode voltage, then only diode is off. That is for sure. I need both voltages to compare. But here, I don't bother about the anode voltage because this is the highest voltage which is going to decide the status of diode. No other choice I have. Guys, correct or not, dear students, right? Now, what is this voltage? Negative, negative, negative voltage, highest negative voltage. N-type semiconductor, negative, no other choice I say, my diode is on. Excuse me, correct or not, diode is what here? On. So, I'm happy to say, diode is on. Interesting. If I reverse the diode, yes, diode will be off. Diode will be off. Highest negative voltage given to the anode, diode will be off. Here, highest negative voltage given to the cathode, diode is on. Right, dear students? Now, when diode is on, tell me, dear, what could be the circuit? Finally, the step 2 is what? Yes, I identified the circuit diode status. Diode status, okay. What is step 3, guys? What is step 3? Tell me, dear students, what is step 3? In the step 3, yes, I need to find the needed quantity. Yes, here I could say there is some 0.7 volt drop because diode is on. Diode is on, and examiner clearly specified that VD on is 0.7 volt. So VD on is 0.7 volt. We are supposed to use that. And of course, here, yes, okay, right. Now here, I can go with what, dear students? Feedback. So it is how much, my dear students? 3K, yes, and this is 1K. This is 1K, and no doubt, this is 3 volt they have provided, and this is ground. And this is what V0 we are supposed to find. Am I right, my dear boys and girls? This is what exactly we are supposed to find. Correct or not? That is the circuit. Now, could you please let me know, my dear boys and girls, if I say this is VOP, and I believe they have given some load also. It's okay, fine. They are not asking about current passing through the load. So just as they have given, we are using it. If the load value is given in the question, in the exam, yes, based on that, the current passing I can easily find. Now, can you please tell me what is the circuit? I think the circuit is like inverting op amp because it's a closed path, negative feedback exists. It's a closed path, negative feedback exists. And moreover, it is inverting op amp, ideal inverting op amp. So, as it is like ideal inverting op amp because they told op amp is ideal. So, whenever I say an ideal inverting op amp, V0 is equals to minus RF by R into Vi, am I right? So, what is minus RF, guys? Minus 3K by R, 1K into 3. So, it is simply minus 9 volt, that's it. So, the output voltage, what we got here is minus 9 volt. Anybody got this answer? So, V0, 9 volt. Oh, Aditya says, wonderful, wonderful, wonderful. So, you got the correct answer. That's fantastic. So, any further answers I got? Fine, dear. Aditya, they have given 9 volt, V0, and they calculated, Aditya said calculated VOP also. Very interesting, VOP. This is VOP. Of course, in the question, they asked to find only V0, I believe. It's okay, let's find VOP also. So this is VOP. If I go with the closed loop, dear students, 0.7 plus V naught. Perfect, perfect. It is how much, my dear? I believe the diode is reverse connected. Correct, correct, correct. The diode is connected in the reverse direction. So we need to connect in this way. Correct, correct. Because the diode, anode voltage greater than cathode voltage. Diode is on. So this is the polarity we are supposed to use. Yes, this is, then it is minus 0.7 plus V naught. So minus 0.7 minus 9. This is minus 9.7 volts. Superb. Superb, Aditya. That is wonderful. So Naresh has given V naught 9 volt. Oh my goodness. Wonderful. Students are giving answers here. I'm so happy. That's wonderful, wonderful. That's great. That's really great. So anyways, I believe you got the points or not, dear students? Wonderful. This is a very simple question. The second question, I think they reverse the diode here. The first question, if you check it out, I mean to say the output voltage VOP is given to the n-type semiconductor here, that is cathode. Here, the examiner simply reversed the diode. This is one of the previous gate questions, okay? One of the previous gate questions. Very simple question, man. If you follow the steps what we have discussed. What are the first step, my dear students? Slowly, let us enter into very complicated questions, okay? Slowly, we'll move into complicated questions. What are the first step, dear students? Treat op-amp as a comparator. Treat op-amp as comparator. First step. Am I right, dear students? If I take op-amp as comparator, now let me know, dear students, what is our op-amp? So, minus and plus, right? And this is simply 2 volt. And here, no doubt, here we have the resistor, which is 1K. This is 1K and this is ground. That's it. It's a comparator. That's it. It's VOP. That's it. Understand, it's a comparator. Guys, okay, whatever the connectivity we have, that connectivity only we need to follow. There is no negative feedback, no diode, no positive feedback, nothing. Now let me know, dear students, what is VOP? What is VOP? So from here it is very clear that this is V1 equals to 0 volt. And of course, V2 is equal to 2 volt. Therefore, what is VID? Differential input voltage, V2 minus V1, so which is simply 2 volt. V2 minus V1. Therefore, what is VOP is positive. Oh my God, this is plus VSAT. This is the largest voltage in the design. This is the largest voltage in the design, which is going to decide the status of my diode. Now connect the circuit. Now for that system, connect the circuit. That's it. Now let me know, my dear boys and girls, what is the second step? In the second step, we are supposed to find the status of diode. First step is done. Just to understand this polarity, first step is done. Now in the second step, we are supposed to find the status of diode. Now let me know, dears, this is VOP, okay? This is VOP, guys, right? So what is the second step we got? That is VOP and plus VSAT. Yes, this is very large voltage. P-type semiconductor given to very large voltage, positive anode voltage is very high. If anode voltage is very, very larger than the cathode voltage, no need to discuss to say diode is on, right? So my diode is on. Very happy to say diode is on. This is the easiest method to understand the status of my device, either diode or BJT or MOSFET or multi-stage designs, whatnot. And guys, when diode is on, then what could be the circuit? Because second point is clear. Identify the status of my device. Now we are supposed to find what? The unknown quantity. What exactly we need here? V naught. And students, yes, students are doing, yes, fine. Now, dears, let me know. How can I find it, guys? How can I find it? Minus and plus. Now tell me, dear students, how can I find it? So diode is on. As diode is on, yes, this polarity is correct. Anode voltage must be positive, cathode must be negative. So positive and negative. This is a right polarity. And this is like 2K. This is 2K. And here, this is V naught, RL, of course. Here there is no use of RL because as per the question, they are not asking to find the current passing through RL. Am I right? Guys, it is like 1K. It is 1K and this is simply 2 volt. My goodness, I think it is like non-inverting op-amp. In the previous case, it is like an inverting op-amp. Now it is simply like non-inverting op-amp. Ideal op-amp, negative feedback. Ideal op amp, non-inverting. Therefore, it is very clear, directly we can go with this. Ideal non-inverting op amp, what is output voltage, my dear students? 1 plus Rf by R. What is that? Rf by R into 2. Correct or not, dear students? 1 plus Rf by R into 2. 1 plus Rf by R. Is this correct? The data 1 plus Rf by R. Perfect. Now tell me, dear students, it is 2 plus 1, 3, 3 to the 6 volt. Wonderful. I got the answer. That's it. Anybody? Yes. Wonderful. Nickel, superb, superb, superb. V naught equal to 6 volt. Wonderful, nickel, superb. So, Aditya, still you're doing? Yes. Anyways, right. V naught is equal to how much, guys? 6 volt I got. And even students got it. I'm so happy. Wonderful. And what is VOP? Of course. I think Aditya must be doing that because without asking, he is doing the VOP also. Wonderful. Right, guys. Anyways, if I go with the VOP, guys, VOP is nothing but 0.7 plus 6, it is 6.7 volt. That's it. 0.7 plus 6, simply equal to what here? 6.7 volt. Great. Now let me increase the diodes. Oh my God. Let me increase the diodes. The same question. Treat it as the same question. What is that question, guys? If diode on voltage, is simply equal to 0.7 volt, okay, and ideal op amp. Treat this as ideal op amp, okay. So find V naught. Find V naught. If you want, you can find VOP also, okay. Output voltage. Find V naught. Simply we increase the diodes. Let us check it out. Whatever may be the case, guys, I just don't bother. We have the 3 important steps because between op amp and load, this is the load. Of course, load they have not given, but the place where output is taken, that is a default load, am I right? So between op amp and the load, if I have diodes, BJT, MOSFET, then no doubt I can implement this technique, this trick, time-saving technique. Am I right? Let us verify that. Could we do that or not? Let me verify. Observe it carefully, my dear students. What is the first step? What is the first step, dear students? Step 1. So op amp as a comparator. Treat op amp as comparator. Treat op amp as comparator. So in that case, yes, this is my op amp, inverting, non-inverting terminal, and of course this is simply VOP, guys, and of course here they have provided 1K, and for that, yes, it is 1 volt supply, and here they provided 3 volt. That's it. That's it. This is a 3 volt. No negative feedback, no positive feedback, nothing, man, no feedback components, because it is a purely comparator circuit, open loop op amp. That is why we are finding here open loop output. Okay, any students? Right. So VOP 6.7 volt, 6 volt. Yeah, previous answer. Wonderful, wonderful, Bhavana. Wonderful, Bhavana. Wonderful, wonderful. Thank you, thank you. So students, and you try this question, man. You should try this. You should try this. Okay, guys, do it. Do it. Wonderful. Now, anyways, check it out here, guys. Like op amp as a comparator. Yes, we got this point. Now, tell me, my dear boys and girls. Tell me. It is like V1, this is what your students, V2. Now what is VID? VID is like V2 minus V1. So this is 3 volt, and of course here the current is 0, therefore the voltage drop is nothing but a 0. 1 volt will be moving here, hence V1 is 1 volt, V2 is 3 volt, so it is positive, right? VID is positive, 3 minus 1, it's a 2 volt, plus 2 volt. As it is positive, no doubt, VOP is as simple as plus VSAT. Fine. This is plus VSAT. Guys, correct? So whenever I go with the plus VSAT here, that is the highest voltage in the entire circuit. The highest voltage in the entire circuit which is going to decide the status. Am I right? So if I say this is plus VSAT, this is plus VSAT, no discussion. D2 will be off because positive voltage, highest voltage given to the cathode, N-type semiconductor, off. Whereas the plus VSAT given to anode voltage of diode D1, highest voltage in the entire circuit, given as anode voltage to diode D1, which is in the positive side. No doubt, D1 will be on. So it is very clear to say that, my dear students, D2 is off. I'm sorry, this is step 2, right? This is step 2. Step 1 is done. I'm going to find step 2. That is, step 2 is nothing but identifying the status of diode. or a device, BJT, MOSFET, any device. So D2 is what, dear students? On. Yes, D2, I'm sorry, that is D2 not here. D2, this is D2, this is D2, this is D2. D2 is off. D2 is off. Why? Because it is the highest positive voltage. This is VOP, right? This is VOP, this is VOP. So as per the comparator design, this is like plus VSAT. Till I have not connected any circuit, okay. So this is the largest plus VSAT, due to which, no doubt, D2 will be off. Whereas due to this VOP, which is plus VSAT, D1 will be on. Correct or not, dear students? So D1 is on. D1 is on. That means at a time only one diode is conducting here. That is intelligent connectivity. And of course, we have discussed this type of circuits a lot in the class itself. Like, I mean to say, if I go with a precision half-wave rectifier, this is one of the circuits under improved precision half-wave rectifier. Why? Because in the normal precision half-wave rectifier, when diode is on, op-amp is under linear. When diode is off, op-amp falls under saturation. So between linear to saturation, there is a huge switching analysis by which there is a chance of getting some distortions at the output. So to avoid that, at the precision rectifier, we always go with improved circuit such a way that even though this diode is on, this diode will be off. If this diode is on, this diode will be off. The two diodes are connected in such a way that at a time, any one of the diode will be on, where my op-amp never fall under saturation. That is a beautiful, intelligent analysis of analog designers. Okay, a big salute to them. Okay, analog designers. Anyways, here our concentration is not the circuit, what is the design, our concentration is the solution, okay, right. So anyways, D2 is, what is D2 is off and D1 is on. Yes, I got the status in the second step. Now what is the third step, my dear boys and girls? What is the third step? If I go with the third step, as per this, I should redraw the circuit. Now tell me, dear students, how could I redraw? So this is minus and plus. Yes, D2 is off, D2 is off. So D2 is off here. Now this is V0, am I right? Now D1 is on, so anode voltage is greater than cathode voltage, 0.7 volt. Yes, now I'm happy to say negative feedback is there. Yes, there is a negative feedback, very happy. And no doubt here there is a resistance. How much, my dear students? It is like 2K. And of course here we have 1K, and this is how much, my dear students? 1 volt. And simply this is how much, my dear students? 3 volt, that's it. It is very easy circuit here. It is very easy. How can we solve this, my dear boys and girls? Any idea? How can we solve? How can we solve? See, we can do directly, or we can go for superposition technique. We can do directly, or we can go for superposition, because negative feedback is there, not here, not from here, okay, from here, negative feedback is there. Or simply, okay, do one thing, guys, do one thing. Array, it is open circuit, right? As it is open circuit, my goodness, the current passing through here is 0. Yes. No need to superposition, man. This is open circuit. As it is open circuit, guys, okay, as it is open circuit, no doubt there is no current propagation. If there is no current propagation, I could say the voltage drop is 0 volt. Oh, my goodness, very interesting design. If the voltage drop is 0, then no doubt this V0 can be reached here. Interesting. That V0 can be reached here. Am I right? Wonderful. And there exists negative feedback. As there exists negative feedback implies there exists virtual short. Why? Because it is an ideal op-amp. There exists negative feedback indicates there exists virtual short, because it is an ideal op-amp. As it is virtual short, this voltage is 3 volt. Then this voltage becomes 3 volt. My goodness. Therefore, V0 is as simple as 3 volt. Interesting. So the same voltage, terminal voltage, 3 volt. Anybody got the answer? Anybody got the answer? Yes, no, still doing? Yes, fine. Anyways, so V0 equal to how much, my dear students? 3 volt. I believe you're getting the points or not, dear students, right? That is interesting. Beautifully, your examiner has asked this question. So anybody got this answer? Let me check it out once again. Oh, still students are doing? Reply, dears. Reply. I'm expecting answers from you. Anyways, I believe you got this. You got this, okay? So, once again repeating, dear students, the very first step, is nothing but treating it as a comparator. The very second step, identifying the status of diode. As this is a positive voltage, due to positive voltage, D2 is off, D1 is on. As D1 is on, this is off. It is very clear that there is no closed path for current propagation, hence current is 0, voltage drop is 0. As voltage drop is 0, this voltage will be coming here. But in this way, there exists negative feedback. That is the beauty of this design. As there is a negative feedback, virtual short exists. Due to that, 3 volt reach here, so V0 is becoming 3 volt, that's it. Very simple answer. Yes, 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 Naresh has given the answer. Wonderful, Naresh. 3 volt, that's wonderful. V0 equal to how much, my dear student? 3 volt. Oh, you calculated VOP also. My goodness. Okay, students calculated VOP also. So let me say this is VOP. My God, they're very fast. So VOP. In this closed way, I can apply KVL here. VOP is equals to 0.7 plus 3 volt. Wonderful, wonderful. So VOP is equals to 0.7 plus 3.7 volt. Wonderful, Naresh. That's great. 3.7 volt. That is interesting. That's interesting, guys. Superb. Anyways, so let me go for one more interesting numerical. So yes, find I out. Okay, I out. Yeah, here. Okay, find I out. If op amp is ideal. I told you number of times, my dear student, this is the output. The place where output is taken, that is the place load exists. Am I right? That is the place load exists. So here, load. Assume it is a load. Okay, output, the load. So between op amp and the load, between op amp and the load, or between op amp and the final output, if any device exists, a diode or a BJT or a MOSFET or multi-stage designs, if any circuit exists in that way, then I can simply go with the 3 steps. What is that? Comparator, second, status, third, solving the circuit. That's it. Am I right? Interesting. So let us check it out, how to solve this, guys. I believe you're getting some conviction. You're getting some conviction because like you have asked multiple questions. Believe you're getting some conviction. Wonderful, dears. Wonderful. Now check it out, guys. Like step 1. What is step 1? What is step 1, dear students? Like assume it as a, otherwise consider it as a comparator. So step 1 is representing what, dear student? Treat op amp. Treat op amp as a comparator. Treat op amp as a comparator. If I say comparator, dears, tell me, dear, what is our case? So this is plus, this is minus. Dear, listen the circuit carefully. I'm going to say observe the circuit. Listen the class and observe the circuit carefully. Okay. So here it is what here? Inverting terminal. This is connected to the resistor with reference to the ground. So this must be connected in this way to the resistor with reference to the ground. Why? Because it's a comparator. Comparator indicates it is open switch. MOSFET seems to be like open. Because still I have not connected the MOSFET here. It is strictly a comparator design. Correct or not, dear students? So whatever connectivity we have for V1 and V2, those connectivities we are supposed to consider. And what is this? It is Vi. Students, I forgot to give that input value. Input voltage, they have given it as a plus 2 volt, okay? Input voltage, they have given it as a plus 2 volt, so take it as some plus 2 volt, okay guys? Plus 2 volt. Fine. Now it's a comparator. Now tell me, dear student, this is like VOP. Now tell me, my dear boys and girls, tell me, this is what, dear? This is what? V2, correct? Correct. This is a non-inverting terminal. This is inverting terminal, which is V1. It is very clear, V1 equals to 0 volt and V2 is nothing but plus 2 volt. Therefore, V2 minus V1, which is VID, is nothing but what, dear students? Positive. If VID is positive, no doubt to say, VOP is plus Vsat. Oh my God. The largest voltage in the entire circuit. Yes, that is plus Vsat. Interesting. Under comparator aspect, that is the largest voltage. Now, what we are supposed to go? Step 2. Correct, dear students? Step 2. Go with the step 2. This is our step 1. Now, I am going towards the step 2. Tell me, dear, what is step 2? Identifying what? The status of MOSFET. Perfect. The status of MOSFET. Now, speak out, my dear boys and girls. This is VOP we got. Am I right? This is VOP we got. It is nothing but VGS. And don't forget about that, the VOP is nothing but what? Plus Vsat, highest voltage. That is for the gate. I repeat, for the gate. You are giving largest voltage in the entire circuit. That is positive voltage. Positive voltage. That means VGS is very large. Speak out correct or not, dear students? So, VGS is very large. VGS is very large, such that VGS will be far greater than VT. What is VT? What is VT? Threshold voltage. Because if I want to switch on the MOSFET, threshold voltage must be there. VGS less than threshold voltage, no channel. VGS greater than or at least equal to threshold voltage, there exists a channel. Because if no condition is given, default MOSFET is always enhancement MOSFET. Enhancement only, or we say enhancement MOSFET. Correct or not? Nobody, I mean to say, in most of the applications we don't use JFET or depletion MOSFETs. Most of the applications like amplifiers, integrated circuits, VLSI designs, ULSI designs, we always go with enhancement designs. So the default MOSFET, what they give in the circuit, it is always enhancement, guys, okay, until unless they specify, it is a default enhancement. And in our syllabus of gate exam, we have mainly enhancement, guys, okay. Now it must be threshold voltage. So VGS far greater than threshold voltage and given NMOS. What is students given? NMOS. Therefore, I am happy to say MOSFET is on. That's brilliant. MOSFET is on. So I am pretty happy to say that I got the status. Yeah, the second step is what? Finding the status. Status is very important. Now the third step, yes, we are supposed to solve the circuit. We are supposed to solve, we are supposed to find the unknown quantity, am I right? Finally, MOSFET is on, I am so happy for that. Now we are supposed to solve the step 3. Step 3. Students, if I want to solve this, I need to identify the feedback, whether it is negative feedback or it is a positive feedback. Correct or not? I need to identify what your feedback, whether it is negative feedback or positive feedback. So what is the procedure? If I want to identify the feedback, break the loop and all the sources must be eliminated, am I right? So what is the step? What is the step to identify the feedback? This is plus minus, see here, to identify feedback. To identify feedback. Because if it is negative feedback, then only I can use virtual short, otherwise I can't. So to identify feedback, I need to break the loop, am I right? Yes, let me break the loop. Yeah. Now, no doubt there must be no sources exist. I am eliminating the sources. No sources must exist. That is what I discussed in the class, right? No sources should exist. And once you break the loop, let me say for my convenience, say it is Vx or Vx dash, take it as some Vx. Guys, and no doubt from here you're taking the feedback and this is the resistor. This is the resistor you connected, of course, right? That is my design. Now I want to ask a small question. My dear boys and girls, please let me know. Sir, feedback indicates what? You're sending a part of output or output back to the input. That means for amplifier output, for amplifier input, the beta circuit output must be there. And for beta circuit input, total design output must be there. That means feedback point of view, this will act as an output. Correct or not? What is this? Source terminal. What is this? Gate terminal. Let me say this is Vy. So what is going back? Please tell me, dear students. What is going back? Vy. Vy is going. Sir, what is Vx? Positive or negative? Positive. Positive. Because I already proved that VOP is positive plus Vsat. If it is positive, then only I can come to this step. If it is positive, then only MOSFET is on. Then only I can come to this step. Otherwise, there itself I need to stop the circuit. Okay, MOSFET is on, right? So this is the positive value. If, what is the phasor relation between the voltages at gate and source, dear? I am asking you this question. For example, if I say I have the MOSFET. See, this is gate voltage. Say this is the source voltage. What is phase angle between? What is phase angle between the gate voltage with the source voltage? If you ask me, it is simply 0 degree, am I right? Whereas, if I say that drain, what is the phase angle between the gate voltage with the drain voltage, I could say this is 180 degrees. In the similar way, what is the phase angle between the source voltage and the drain voltage? Again, it is how much? 0 degree. This is what we study in our analog circuits. We discussed a lot in the class. That means VG, Vs, that means assume it is input, okay, let me assume this is input, assume this is output. Then it is like a common drain system. Input is given to the gate, output is taken across the source, hence it is like a common drain system, common drain. For common drain, yes, phase angle is 0, because it is like a source follower, phase angle is 0. Whereas input is source, output is drain. Input is source, output is drain. It is like a common gate, yes, phase angle is 0. Input is gate and output is a drain. Input is gate, output is a drain. So it is like a common source, common emitter. Altogether almost a similar response. So phase angle is 180 degrees. Am I right? So now check it out, guys. So if it is plus Vx, of course it is Vy, the other value, but it is positive only because the phase angle is same. Positive. I mean to say phase angle is 0. Phase angle is 0. The polarity must be same. So that Vy is moving here. So it is plus Vy. It is what, dear students? Plus Vy. Now let me know, dear students, V2 is equal to 0 volt. This is V2. This is what, dear students? V1. Whereas V1 is equal to plus Vy. Now speak out, guys. What is VID? VID, which is nothing but what? V2 minus V1, which is nothing but minus Vy. Now what do you mean by the loop gain, guys? Beta AD. Why? Because what is Vx dash? Vx dash is equals to differential gain into VID. Am I right? This is differential gain. So Vx dash is equals to differential gain into VID. Correct or not, dear students? So what will be beta AD? It will be negative. Why? Because VID is negative. If VID is negative, the loop gain will be negative. Tell me, dears, if loop gain is negative, it is nothing but what, dear students? Negative feedback. It is what, dear students? Negative feedback. This is what we discussed, how to identify the type of feedback. I told you to recollect that concept, which is very important. So the loop gain is negative, hence it is negative feedback. Clear? So the circuit, what they have specified in the given question, it's a negative feedback system. As it is negative feedback, yes, I can apply virtual short because it is an ideal op amp. Now I can easily get this answer, guys. I can easily get this answer. So if it is 2 volt, yes, it is also 2 volt because of negative feedback. Then no doubt this voltage become 2 volt. And of course, this current is 0. If it is I out, so it will be also I out. Why? Because source current is always equals to drain current in case of MOSFET. Drain and source could be interchangeable. Am I right? So this current equal to 0 indicates this current will be I out. Therefore, I out is as simple as 2 volt by R, which is nothing but Vi by R. That's it. Vi, what I have given is 2 volt, so I could say 2 volt by R. That's it. A very simple question. One of the previous engineering services questions, guys. Very simple question. But you need to justify. If it is negative feedback, then only you can do this. Otherwise, you can't. Let me do one more example. By that, I believe you get some conviction. Okay. Let us do one more example. So 2 more questions. And any students, they are giving answers? Okay, Sakshi, you have given right. Okay. What about the remaining answers? Are you giving? Students, try it out. Try out the questions. Please take care. Do the numericals. Put pen on the paper. You really enjoy. For sure. Yes, okay. Anyways, so find IRL if op amp is ideal. Find IRL. Okay, the current passing through the load, RL, if op amp is ideal. Okay, the same case. See, between op amp and the load, if a diode or a BJT or a MOSFET, any design, okay, follow the steps, shortcuts, I can say time-saving techniques. You need to save a lot of time, man. That is a complete exam. And most of the numericals, what I'm doing here are 2 marks questions. Very first question, second question, maybe like, it seems to be like 1 mark, but it is also the 2 mark questions, previous gate questions as I discussed already. Understanding, dears? So anyways, go through here. Like, what is step 1? I'm sorry. Yes, step 1. What is step 1? Comparator. Step 1, right dear students? Comparator. Treat op amp as a comparator. So let us make it fast. So this is what here? VOP. What is this voltage, guys? It is plus 2 volt. And don't forget, it's a comparator indicates U of the BJT, no negative feedback, nothing, man, nothing. It's a comparator, that's it, no connectivity. Indicates this wire is connected to 10K and 5 volt, that's it. Don't forget, that means what? That means what, dear student? This is connected to what, dear students? 10K, and this is 5 volt. Is understanding? So this is what they connected to 10K and connected to 5 volt. That's the connection. Because it is a comparator, no output, I mean to say, that there will be no device connected to the output. It must be no feedback. There must be no feedback, no negative feedback, no positive feedback. Guys, try to understand, please, okay? Now let me know, my dear boys and girls, what is this? What is this exactly? VOP. What is VOP here? What is VOP? Right. Tell me, dear students, what is VOP? Now this voltage become 5 volt, am I right? No drop, so it become 5 volt, it become 2 volt. So V2 is 2 volt, V1 is 5 volt. Am I right, dear students? So what is VOP? Oh my goodness. So V2, I'm sorry. What is VID? What is VID? VID is V2 minus V1, which is negative. My goodness. V2 minus V1, 2 minus 5. Yes, it is negative. It is negative. So it is, in that case, VOP is minus VSAT. Minus VSAT. Okay, this is minus VSAT. So this VOP, what we got here, it is minus VSAT. The largest voltage in the entire design. The largest voltage in the entire design, yes, I got here it as minus VSAT. And you know, this is one of the previous gate questions, guys. Yes, one of the previous gate questions. Observe an important point clearly that, my dear boys and girls, I believe this is the question asked for instrumentation. And you know, once the key, examination key was released, okay, they have given some answer, but after 2 to 3 days, they have modified the answer, guys, okay. They have done that there exists some answer, but there is no answer. Why? Because here, VOP is negative, minus VSAT, the highest voltage in the entire design. If I provide that voltage to the bipolar junction transistor, emitter junction is reverse bias. If emitter junction is reverse bias, it is simply cut off. Cut off indicates it is open switch. So current is 0. So in the options initially, I'm going to say initial key what your IIT panel released in 2018, I believe, this is the question of instrumentation. They have given the current passing through the load, which is a non-zero value they have provided. After 2 days or 3 days, I believe, they have modified the key. Yes, okay, please take care. Students are doing the mistake, and you know what some students asked me this question. Sir, input is given to non-inverting terminal. This is non-inverting. If input is given to non-inverting terminal, it is over. VOPV is positive. I'm repeating. Sir, input is given to non-inverting terminal. As input is given to non-inverting terminal, it is over, sir. VOP is positive. Who told you that? Is there any shortcut or what exactly? VOP will become positive based on VID. Okay. So if VID is positive, VOP will be positive. VID is negative, VOP is negative. Who told you that? If input is given to non-inverting terminal, VOP will become positive. I don't know, that a tricky shortcut. I think that is not at all a shortcut, man. That's no concept there. Please take care, guys. Okay. Even the input is given here because of the biasing elements, what they have used in 10K or 5 volt like that. Okay. This voltage has become a larger voltage, due to which inverting voltage is larger than non-inverting. So VOP is becoming negative, minus VSAT. Now this is NPN transistor. This is what your NPN transistor. This is the PN junction. This is, I mean to say, base emitter junction, am I right? This is like a base emitter junction. Because bipolar junction transistor can be comparable with the diodes, PN diodes. Correct or not, dear students? Now check it out here. I mean to say VOP is a largest value, so-called negative value. It's a negative largest. So P-type semiconductor, largest negative is given. What do you mean by that? Open switch. It is what here? Open switch. So what do you mean by that? Here BJT is in cutoff. So this is step 3. This is step 3 because I mean to say step 3, not step 3 here. this is step 2, sorry, this is step 2, because step 2 represents identifying the status. So in step 2, I got a clarity that BJT is in cutoff. If BJT is in cutoff, it is absolutely an open switch. Cutoff indicates what? An open switch, because emitter junction is open. Why? Since emitter junction is open, indicates BJT is cut off. Now what is step 3? The final answer. Now it is very easy answer, damn easy answer. What is step 3, dear students? What is step 3? The emitter current equal to 0, because cutoff indicates open switch. Of course, microampere, nanoampere currents propagate. Analog designs, we always go with milliampere currents, so I can take it as 0. Right, dear students? So emitter current is 0. What is emitter current? The current passing through the load RL is equal to 0. That's it. That current equals to 0. Guys, I believe you got the point or not, dear students? Very interesting. Now, no need to verify whether there exists negative feedback or positive feedback. No, I got the answer directly. Why should I go for, again, feedback? There is no feedback, man, because this is open switch. If it is open switch, where is feedback? If no output, where is feedback? Output should send back to input. If no output, where is feedback? Guys, okay? And see, of course, I understand we are approaching very near to 8 o'clock, but it's okay. Let me do this numerical also. By that I feel very happy. Okay, my students can gain something. That is my intention. Is it okay, guys? So take this, one more interesting question, one of the previous gate questions. Okay, and you know, one more biggest mistake the students what they're doing is, sir, output is connected back to positive. You know what they're saying? So this is output. I mean to say sending output back to the input, or a part of output back to the input is feedback. So if I'm connecting a feedback wire indicates, it is one of the part of output. So this is connected to the positive terminal, hence it is a positive feedback. Don't conclude that, dear. Okay, don't conclude. Okay, if you are getting any sort of logic, first you confirm it. What thought you got, what idea you got, you please confirm first, then only conclude. See, without confirmation, don't conclude it. My humble request to everyone. You're preparing for competitive exams. Most precisely, you're the students of ACE Academy, right? How can you do mistake, man? Correct or not, dear students, right? You're having a very good guidance from the professors, right? And moreover, preparing for IIT entrance examinations like GATE. So don't conclude what thought you got. Don't confirm it is a positive feedback. Please, man, verify it, because we have some steps to verify, right? Please verify. Before that, I need high concentration, guys, please. High concentration, I think, yes, students, yes, you're there, right? I'm happy. Okay, I need high concentration, my humble request to everyone. Students, please let me know what is step 1. What is step 1? Yes, comparator, op-amp as a comparator. So when I say comparator design, speak out, guys, minus and plus, what is that? I'm sorry. So, right. Tell me, it is plus and minus, am I right? Plus and minus. What is that here? It is 2 volt. The VI 2 volt. And of course, 1K could be connected here. This is what, dear students? 1K. This is 1K. And this is 5 volt. And this is VOP. Am I right, dear students? Yes, fine. Correct. Right. Believe got it point, dear students? Everybody in the class? This is how much, my dear students? 2 volt. And 1K could be connected because it is an open loop op-amp. So no transistor, nothing here. That's a pure comparator. So this is the wire which is connected to 1K and of course plus 5 volt. That is what I have connected here. So it is open secret to say this is 5 volt and this is what here? 2 volt. So V2 5 volt, V1 2 volt, therefore VID V2 minus V1, which is positive. Goodness, that's great. So 5 minus 2 plus, okay, it's plus 3, positive. Therefore, VOP is plus VSAT. So the largest voltage in the entire circuit, is plus VSAT. Yes, I got it as a plus VSAT. This is VOP, right? So it is like a plus VSAT. Yes, this is NPN transistor. So largest positive voltage given to the P-type semiconductor. Largest positive voltage given to the P-type semiconductor because it is PN junction, emitter junction. So open secret to say my BJT is on. Yes, this is interesting question. My BJT is on. Now I can move towards the step 2. I can move to step 2. Tell me dear students, in step 2, it is very clear to say my BJT is on. I don't know whether it is forward active or saturation. I really don't know that. But okay, BJT is on. That is the confirmation I got. My BJT is on. When BJT is on, BJT will conduct for sure. BJT will be conducting. Correct, dear students? Right. Now step 3. I need to find the final answer. What is IRL? Step 3, to find the final answer. Students, now please let me know. Step 3. Please let me know, my dear students. If I want to solve it, first of all, I should know whether it is negative feedback or positive feedback. Correct or not? So identify the feedback. How can I identify the feedback? How can I identify the feedback? Same technique, what I have discussed clearly. Break the loop. So let me break the loop. So this is plus, this is minus. Break the loop, guys. Break the loop. Okay, fine, fine. Yes, same case, take it as Vx. Some take it as otherwise Vx, okay, Vx or Vx dash, anything man, anything, no problem. And from here you're taking the feedback, so take it as Vy. Okay, from here you're taking the feedback, so just for convenience take it as Vy, and here the resistor he has given 1K, this is plus 5 volt, and of course here it is RL. This is RL, right dear students? Fine. Now this is how much, my dear students? Plus 2 volt. Okay, this is what exactly they have provided, right? Right, fine. Now excuse me, can you please tell me the phase shift, the phase angle, phasor relation between Vx dash and Vy? Can you please tell me the phasor relation between Vx dash and Vy? Vx dash and Vy? Any answer? Anybody is giving answers? Naresh, Sakshi, I need answers please. Any answers? Very simple logic. This is base, this is collector. Base voltage, collector voltage. The phase angle is 180 degrees. What is that? 180 degrees. For example, if it is plus, it must be minus, no other choice I have. If it is plus, it must be minus. And if you want to find the type of feedback, I forgot here, yes, I should eliminate the sources, am I right? I should eliminate all the sources, right? So tell me, my dear boys and girls, once again tell me, if it is plus, it must be minus. Is it plus? Yes, plus V sat, very largest value. Very largest value. If it is minus, here itself my BJT will be off, like the way how we have done the previous numerical. If it is minus, here itself my BJT will be off. I never come to this step. I never come to this step to identify the type of feedback. Is okay, correct or not? So tell me, my dear boys and girls, right? So no doubt it is always positive. It is positive, plus V sat, largest voltage, okay? It's positive voltage. If it is positive, then this polarity must be negative. Negative, 180 degrees phase shift, negative. So it must be minus Vy. It's not plus Vy. It is what here? Minus Vy. Phase angle between base and a collector, 180 degrees. Phase angle between emitter voltage and collector voltage, 0. Phase angle between base voltage and emitter voltage, 0. Phase angle between base voltage and collector voltage, 180 degrees. Example, common emitter, 180 degrees. Example, common emitter, phase shifter. Whereas common base, phase buffer. Common collector, phase buffer. Am I right, guys? Recollect the classes, what I have discussed in the class, right? Now this is minus Vy, so it is minus Vy. Now tell me, dear students, this is differential gain. Now can you please tell me, I mean to say, what is Vx? Vx is equals to differential gain into minus Vy, and no doubt, what is that? The VID, what we got? V2 minus V1, V2 minus V1 is negative. So VID here I got negative, therefore loop gain will be what here? Negative. As it is representing loop gain negative, it is a negative feedback system. Oh my God. See, the biggest mistake you have done previously, as the wire is connected to place, hence it is positive feedback, the blunder, that is the blunder mistake. It is not positive feedback, man. It is a negative feedback system. This is the reason why I am discussing these questions here, because many students are asking me questions that, sir, it is positive feedback. How examiner applied virtual short? Because examiner, of course, the previous gate question, many solutions, yes, they have directly applied the virtual short and they processed. They have not given any proper explanation of this. That's the reason why I have chosen this question to explain in a proper way. Please take care, my dear boys and girls, okay? Right? It's not a positive feedback, it's a negative feedback. And some students asked me, sir, it's a Smith trigger. Why? Sir, positive feedback. A comparator with the positive feedback is a Smith trigger. How can you apply virtual short? Then I said, may God bless you. That's it. What could I say more than that? Okay, dear student, don't conform, man. Don't conform. That means, I mean to say half knowledge is a dangerous knowledge in a human life, what I believe. Don't conform. Do some work. Do some work, please, guys, okay? And guys, I believe we got it. The loop gain is negative, hence it is what here? Negative feedback. Now, proudly I can apply virtual short. Yes, I can apply virtual short. Now, tell me, dear students, if I apply the virtual short, so here itself I can do the numerical, guys, okay? This is 2 volt. It is also what, my dear students? 2 volt. Now, no doubt, this voltage is 2 volt. Now, here what will be the current? The current I is equals to 5 minus 2, 3 by 1K, which is 3 milliampere. Am I right? 5 minus 2 is 3, 3 by 1K, 3 milliampere. Correct? And of course, this current is 0. So now this current will be I. Am I right? This current will be I. Guys, beta 200. Commonly in analog circuits, we always use the beta value in the order of like 80, beta equal to 50, beta equal to 80, beta equal to 100, beta equal to 140, like that. But 200, 250, I believe it is very large value. If the beta is large, base current is very, very, very small. Okay, base current is very, very, very small. Then IE is approximately equal to IC. IE, the emitter current, is approximately equal to IC. So I can approximate it, and I can say IE, which is equals to IRL, almost approximates to IC. Therefore, I'm happy to say IRL, because this current is nothing but IC. Am I right? Current passing through the collector terminal is IC. So IRL will be equals to IC. IC is nothing but I is nothing but how much, my dear? 3 milliampere. That's it. We got the answer. Guys, understanding or not? If you feel it is a positive feedback, just you think, man, a blunder mistake you must experience here. Please take care of that. So I believe in the span of almost 1 hour, 5 minutes, we have concluded how many numericals first? I can say second, third, fourth, fifth, sixth, 6 numericals. We covered 6 numericals, guys. Not only that, I have given you one very interesting trick, the shortcut. The trick what I have given to solve the diode circuit, transistor circuits with op-amp. Mainly if diode and transistor connected between op-amp and load. These type of circuits, right? And the shortcut trick I have clearly mentioned here, and I have done 6 numericals. Students, you please tell me, out of 6 numericals, 5 numericals are 2 marks questions. 5 numericals are 2 marks questions. In one hour, 5 2 marks questions I have done. Commonly, to explain I have taken more time, I believe. To explain I have taken more time. But if you can implement this shortcut, this technique for those numericals, maximum within 2 minutes you can able to solve the circuit. Maximum within 2 minutes you could able to solve the circuit. 2 marks questions you are solving in 2 minutes indicates. IIT people, IIT panel for the gate, 2 marks questions, the allotted time is almost like 5 minutes, but you're able to solve within 2 minutes. That's great, man. Okay, that's great. That is what we need. Okay, so proper professor, proper guru is very important. Proper organization is very important to teach the concepts. Right, dear students? I am one of the faculties of ACE Academy. My name is Thrinadh. I teach 2 subjects, EDC, analog circuits. Guys, okay? So you can experience a lot of techniques, a lot of shortcuts, a lot of tricks like this in ACE Engineering Academy and have a healthy, wealthy career for your life, dears. Don't get afraid. Just follow the yesterday video, what I have discussed, the preparation strategy. And today, understand about the tricks and understand the way how we need to prepare the short notes, which is very important. Guys, okay? Give a kickstart for the preparation and have a great future. Thank you so much. Jai Hind.